In this video, I will show how to use the integral test to determine whether the given series is convergent or divergent. So before we use the integral test, we have to make sure that the corresponding function, in this case, the corresponding function is 3x squared over x to the 6 plus 1 is continuous. So in this case, everything is positive. The denominator is never equal to 0, so it is continuous. 2 is positive. So in this case, since everything has even powers, everything is positive. And 3, that f of x is decreasing. So how do we make sure that f of x is decreasing? To make sure that f of x is decreasing, we can consider the derivative of the function. So in this case, the derivative is 6x times x to the 6 plus 1 minus 3x squared times 6x to the 5 over x to the 6 plus 1 squared. We have 6x to the 7 minus 18x to the 7, that's negative 11x to the 7. So we have 6x minus 11x to the 7 over x to the 6 plus 1 squared. And if we construct the sign chart for this function, so let's say we factor out 11x, so we have negative 11x, so we have x to the 6 minus 6 over 11. We'll see that for the x values greater than 1, this is strictly negative, meaning that the actual function will be decreasing on the interval from 1 to infinity. So this is something that we have to do just to confirm that the function is decreasing. So it's not part of the integral test. Now, once all 3 conditions were verified, now we set up and perform the integral test. So the idea is that once the conditions were verified, the claim is that this series acts exactly the same way as the integral from 1 to infinity of this function. And all we have to do now is to compute this integral from 1 to infinity of 3x squared over x to the 6 plus 1 dx. So to compute this integral, we're going to do the substitution. So we're going to substitute x cubed with t. So dt is equal to 3x squared dx. And the limits of integration are when x is 1, t is 1. When x is infinity, t is also infinity. So the limits of integration do not change. So we have integral from 1 to infinity dt over t squared plus 1. So antiderivative of this is arctan of t. The limits of integration are from 1 to infinity, but I can't use infinity, so I'm just going to use b. And we're going to send b to infinity. So this improper integral is equal to the limit of arctan b minus arctan 1 as b goes to infinity. Arctangent of infinity is pi over 2. Arctangent of 1 is pi over 4. So this overall limit is equal to pi over 4. So since the corresponding improper integral converges, we also conclude that the given series converges. And the reason why is by the integral test. So this is how we set up and perform the integral test to test a given series for convergence.